Hey guys, welcome to Vinny's Lab, and today is Laser Day! So I have a massive laser here, a big laser power supply, and we're gonna have a look into it. So I'm gonna start removing the covers and I'm gonna show you. And then when I give an explanation, we go to the bench and I'm gonna show you the parts in detail. So this is a YAG laser, and what means YAG basically is the nomenclature for yttrium something else. So basically this is a solid state laser where you have here in the middle two flash lamps. Usually they are xenon or krypton lamps, and they provided a pulse of high intensity lens. And then these crystals in the middle, it basically emits a high intensity pulse. And so basically the laser is split in different parts here. So I'm gonna start from the bottom. And the first thing that we see here, and don't worry, I'm gonna go to the bench afterwards and show you in detail. It's a Helium neon laser. This is a red laser, and this is actually not necessary for the high intensity laser at all. But this laser here, it's an indicator when you, for example, you are cutting sheet metal, for example, you need to align your sheet metal. So this is a reference laser that is just used so the operator on the machine can identify and align the parts to do the proper cutting. So it's just something extra that they put to make life easier. And we're gonna turn on this and we're gonna check if it's working. Afterwards, we have what we can call the resonance chamber. So basically we have a mirror here, and this mirror it's basically 100% reflective, and we have here an output mirror that it's 90% reflective, and it lets the 10% goes out. So this is the resonance part, and this is a key switch laser. What it means? Despite that this laser is a pulsed laser, it has an additional optical switch here, that is this box that's called a key switch. Basically, this is a non-linear crystal that you can basically feed with a ref, and this crystal, it basically works like a shutter. So it reduces the quality factor of the resonance chamber to not let the laser. So what it does, it puts the crystal here in the middle in saturation until you get the highest level of energy in the crystal, and then this switch triggers and release an extremely high intensity pulse. So with this technology, instead of get like a few hundred watts of lasering power on a longer pulse, you can get like nanoseconds of kilowatts or megawatts, depending on your laser size and power. So this is a very interesting technology. So this is basically the part that builds the lasering, and we have these two mirrors, and you can see that the key switch is in the middle of the resonance cavity. So when it is triggered, it basically lets the amplification happens of light, and then you have your pulse. And because it is based on a flash lamp, a xenon lamp, then this pulse is gonna have a limited amount of energy, and then you recharge and you go pulse after pulse, and you have basically almost a continuous laser. Usually these lasers, they are gonna switch around 10 kilohertz more or less. So in the end, the practical ways, when you're like cutting metal, for example, it's almost continuous. And here we have in the output a bin expander, and this is a bin expander is very interesting because when you're talking about high intensity lasers, you have all your optical system after the laser itself. So you have your mirrors, and then you have your collimator lens on the laser head. And if you're working with really high intensity pulses like this, your lens and mirrors, they're gonna deteriorate with time. So what this expander does, or in a tiny point, it increases the diameter of the beam, so you can increase the performance. It's not exactly the performance, but you reduce losses and wearing on your optics afterwards. So it's a very neat optic system, and we're gonna have a look at as well. So now I'm gonna remove the individual parts, and we go to the bench, and I'm gonna show you the details of those parts. Okay, so let's go there to the bench. So here we have our first part, that is the helium neon laser. And basically this laser is a light bulb. Let's consider that it looks more like a fluorescent bulb. We have a high voltage transformer here that produces very low current. We have some limiting current resistors here. And then we have the lamp. And the lamp has 100% mirror in the back, and it has a partial mirror in the front. So let's turn this laser on. It needs 12 volts, around 700 milliamps. So almost 10 watts. So as you can see here on the wall, it has a very tiny dot. And so yeah, cool, nice. So red laser. And I already got the beam expander here because since I have this laser working here, I'm gonna show you the expander capabilities. So what I can do here, I can just point out this laser that has this tiny dot. So here you can see there, it's a very tiny dot. I think is around 3 millimeters. And then we can place the bin expander in front of it, and I can align it, and there you can see we have a way larger dot, around 10 millimeters, more or less, from 8 to 10 millimeters based on what I can see. I basically changed so let's turn this off because it has high voltage and I already got a shock here. And I don't want another one. So this bin expander is extremely nice. It's zinc selenite lens, and it's an adjustable bin expander. So as you can see here, I have those rings here, so I can change here the ratio, and I can change here as well. So it's a very interesting and very expensive optic set. And I'm really glad that the laser came with it. So now let's move on, and I'm gonna show you the key switch. Okay, so here I have the key switch. So as I said before, this is basically a crystal that works on a non-linear way. And as you can see, it's a massive crystal. You can see here my hands for the crystal. So when the crystal doesn't have a signal, it basically works as a piece of glass, so it doesn't do anything. So basically here is in the triggered mode, and as you can see on this side here, it has an BNC here, and here is where an RF signal gets into, and this is basically an impedance matching network here. Works more or less with 30-40 watts of RF power. And when the signal is injected here. Basically this crystal, it changes its behavior and it starts to block the laser. So this way the switch is able to not let the resonance chamber to laser and to amplify the light, and this way we can maximize and saturate the crystal, the neodymium yttrium crystal in the main chamber that I'm gonna show you afterwards. And this way we can just trigger for a few nanoseconds and have that massive boost. So it's a very interesting, very expensive. Those goes for more or less 50 to 100 euros on eBay if you can get one of those. And don't ask me how much it costs a new one, because yeah, probably we can't afford it. So let's have a look now on the main xenon chamber. Okay guys, so what you can see here now is the main star of the show. So this is basically a big ass water block, and here in the middle you can see this gold surface, and this is actually gold, it's gold plated. And the reason for that is we have two xenon lamps here that produces very high pulses of light, visible light. And then this water block, this gold part here, basically it's a reflector that reflects most of the lights to this part here in the middle, that is the crystal, the YAG crystal. And what it does, it saturates and produces the laser on this crystal. So everything is very reflective here, and I have a light there, so it's very hard to show you guys. So I'm gonna disassemble this so you can see in detail each one of the parts. So as you can see, this is the reflector, and it has this arc shape. And then we have here the lights and the crystal. And as you can see, there are those tubes, and they are quartz tubes. And the reason that they exist is because actually water flows through the crystal and through the lamps. Because the amount of heat here is massive, so this unit needs massive cooling to keep everything cooled down. So I'm gonna get one of the lamps here. So this is a flash lamp, and this one it's one of the sides of the electrodes, it's pretty okay, but the other side is basically damaged. Sorry if the focus is not working properly, but it's really hard to focus. So it looks like it's oxidized, so I imagine those lamps are gone. Alright, so I'm gonna need a replacement if I want to make this laser, put this laser to work, and I want to. Yeah, so there are two of the xenon lamps, and we're gonna find out in the future replacement for them. And the main star of the show is our crystal, YAG crystal. So it's very delicate, and as you can see, it has this purplish pink color of it, and basically it's the dopants on the crystal. And this is our solid state crystal that lasers when you put into a resonance chamber. So those are the lamps and the crystal. And don't get to fool yourself thinking, oh, this is a very tiny crystal, but this laser can produce very high density pulses, very powerful pulses. And yeah, and I'm looking forward to make this laser operational. So guys, this is basically what I have for you today. I'm sorry, I would like to have more content, but life is hard these days. So if you wanna see what's gonna happen with this laser, please consider to subscribe If you wanna know about any additional detail about this technology, leave a comment below, and I'll read all your comments. So see you next time.